God. Uh, because this week has been a hectic week, and hence So I get up at 4:30 every day in UK because my workshops with customers start at 9 o'clock.
Oh my goodness! Wow.
So,
Okay.
yeah,
So
next 10 days I'm back in India, so it should be okay.
okay. So it's 6:30 in the morning for you, pretty much now,
Yeah,
right? I guess.
right now it's 6:30 in the
Oh,
morning.
okay.
Perfectly.
Oh, I wish I had known. I mean, we could have arranged it for a more suitable time for you.
No. It's perfectly fine. It's a great way to start a Saturday. Nothing like it.
So are you in the UK quite a bit? I mean, is this a work-related
No.
trip or?
No, basically my daughter starts her undergrad, and
Where?
I've come to see her in Nottingham, Trent University.
Okay,
So
nice.
just come to see her off and then get back. Yeah.
Okay. So I of course spent 22 years in the UK, right? And part of it was teaching at Warwick. So
Wonderful.
that's actually home for me now in some
wonderful.
ways.
Wonderful.
So
Good to know that.
Yeah. So I mean, actually, if at any point you need any support there, I mean, I have a big network of friends there.
Oh, wonderful.
Nottingham is not too far away from Warwick, and so we can definitely let me know.
Wonderful. Thanks so much, Sarabjit, for that. Appreciate it. Yeah.
Because I've been working for Microsoft, you probably have a network of people there in any case that you can probably lean on, right?
It's always good to know, they can lean on. Yeah, absolutely.
No, and absolutely. And I actually know people from Nottingham too. So, I mean, not from the university, but definitely from that area. So, really, if there is anything, I really mean it.
Perfect. I'll definitely join. Thanks for that.
Great. But anyway, I mean, thank you for, taking the time out despite being in the UK. So I really appreciate the fact that you have woken up early to be here. And, it's a pleasure to be connected with you in any case from a training perspective that, the initiative, the NASCOM, and you are running, which is, a fantastic program that you're running. And I really appreciate what you're doing for students, there. And in our own little way, we are out here trying to get students up and running in AI machine learning, run quite an extensive curriculum, as you know, and then get them to work on projects as well, live projects that have social impact.
Wow.
So, we are really looking for, a great talk today to understand, the Microsoft initiatives in this space. I remember Microsoft being an early adopter of AI, in fact, well before even Google existed. So, when Microsoft was looking at Bayesian belief networks and using them for the diagnostics in, printer diagnostics and so on. And in fact, I think Rakesh Agarwal also moved from IBM to Microsoft, right? And that was a big move. So we look forward to seeing what the result is of all the research that goes on in Microsoft, and what tools you have. So I'll hand over to you, and there will be people joining along the way, but I think maybe we can start.
Perfect. Thanks so much, Sarabjit. And have 60 minutes?
Yes, but again, we don't push for it to be closed in this time. I mean, if there are things that you were inspired by that you want to talk about, don't worry about time. Right?
Perfect.
The students are here to just lap up everything you're telling me.
Wonderful. Thanks for that. And I'm going to just share my screen.
Sure.
And you can just confirm that'll.
Yes, it's visible.
Yeah.
That doesn't look like England.
No, it doesn't. If I remove the background, it's quite dark outside.
All right.
Wonderful. All right. Thanks so much, Sir Broj. Appreciate it. First of all, thanks for inviting me. And it's nothing like starting a Saturday with a tech talk. So I'm absolutely pleased to be talking to all of you this morning. And again, thanks for joining in as well. Saturdays, I know all of us spend significant time in the weekday learning, etc. But Saturday also investing time in learning, nothing like it. So thanks once again for that. So a bit of introduction on my end. My name is Sandeep, and I work for Microsoft. And at Microsoft, there's a unique group called Microsoft Technology Center. And that's one center in the country in Bangalore. And I head that division. The pictures that you see here on my screen right now is basically the facility, and I miss that facility immensely, because all of us miss going to either the campus or to the offices, and that's me, and I absolutely miss that. But here we are, virtual world is caught on, and nothing like staying connected all the time. So I'm glad technology is helping us make that happen. Yeah. So for the next 30-40 minutes or so, I'll spend some time just to give you my perspective. When I say my perspective, I get to meet one customer every day at the tech center, today virtually though, in the current times. So my talk dominantly leans towards what is working for the customers, what is not working for the customers, what are some of the innovations that we are doing as Microsoft, and what are some of the innovations that are dominating when it comes to, I use a term called democratize AI, right? Now, AI is definitely, it's a complex world. Anything that involves mathematical models, mathematics, statistics, etc. It's not easy. It's quite complex. Now, how can we make it easier for end user data scientists, ML developers? That's where bulk of effort is going in as Microsoft. So I'm going to bring in that perspective also into the talk. Okay. So with that, let's get started. So now, I'm sure all of you agree with this statement that future is definitely discontinuous. It's not linear, right? You can't take something that has worked in the last decade or so and extrapolate that to the next decade. It doesn't work that way, and it's definitely disruptive, right? And more so in the current times. Look at it. All of us are able to handshake virtually, get connected, stay connected, thanks to technology. And truly, if you look at currently, we are in Zoom, with Microsoft Teams and Google Meetup, etc. So they're all pretty, I would say, disruptive in the current times. And thanks to those innovations, we're able to stay connected. But more than anything, I think we're talking about transformative experiences, right? When it comes to technology, how can technology be used to make a difference in the society? Right? I know Sarabjot mentioned that a lot of you take up some of the social impact projects and deal with it, which is phenomenal. Great to hear that. I was a student a couple of years back. I did my post graduation at ISB on data science. Now, my final capstone project was also in the social impact sector. I'm closely associated with a group called, I think it's NGO. It's an NGO called Samarthanam Trust for the Blind in Bangalore. Now, we took a project there to see how computer vision and some of the mathematical models can help people who are intellectually disabled, right? We call it ID, right? So be it autism, cerebral palsy, how can computer vision and some of the mathematical models when it comes to designing a learning path for them, because each of them is unique, and you can't have a standard set of curriculum for them. So that's something which we did as a pilot, but yet to go live with that. Because of COVID, we couldn't make it happen. But that's where I'm associated. That's where I find a purpose in using technology for social good, and I'm glad some of you are doing that as well. Now, talking about innovation, so what you're seeing on the screen is 2 weeks old, announcement from Microsoft, right? We all talk about pre-built AI, right? If you look at the technology providers like Microsoft, we offer cognitive APIs, cognitive services, and we also offer a platform where you can build custom machine learning models. But if you look at the way technology is being built and released to the public, we're trying to make it simpler and easier depending on what the industry wants. Consider the current times where social distancing is a necessity, and social distancing will be a necessity going forward as well. It will be there for a long time. Ability for us to identify how many individuals are there in a specific aisle of a retail store, right? How many people are there in the front office of a hospital? So making sure that there is enough social distancing, and making sure everybody wearing a mask as the simple. So these are the two use cases that is dominantly being put to practice by every single, I would say, school, college, hospital, offices when it comes to returning back to our facilities, right? So this is again a pre-built AI where we're trying to help you do three things. One is do people counting. Second, to understand what are the distance between individuals there in terms of feet. And number three, which probably is the most important one, is identifying when somebody entered a specific zone and when they exit a specific zone. What that really means. Imagine you put a boundary in the computer vision's near field of view or a far field of view, right? Ability for you to mark a zone there, right? Imagine in a manufacturing plant, there may be specific zones where human intervention is not expected there because of safety and health hazards. If somebody by mistake enters that zone, there should be an alarm there, right? So you can define zones, or even for in a retail store, when people are standing in a queue, you can define a zone which says in this zone at the max there has to be only 10 people. Beyond that, alarm has to come in because there is going to be a problem in terms of social distancing. So use cases are umpteen. My point is, as a company, we're looking at innovating where we give you these models, right? And by the way, we give you this model in containers and tell you why that is so. Okay, so this is one glimpse of where industry is heading and how are we making it easier and simpler for developers and software application development creators in terms of infusing AI into their applications. By the way, using this API, you don't need to be a scientist. You can be a regular developer, and you can invoke this API from your application. Now, there are two themes, right? While I just give a glimpse of one, recent innovation. But if you look at theme, yes, two themes are fast emerging in the industry. Number one, intelligent automation. Second, autonomous systems, right? What is intelligent automation? I'm sure all of you would have heard the term robotic process automation, RPA, in the short form. Now, RPA is getting significant traction in the current times. At least in the last 90 days, where I've spoken to at least about 50, 60 customers. Each one of them have expressed interest, or rather, some work is deeply happening in the RPA space. Now, because of AI, RPA plus AI is termed as intelligent automation, and dominantly, every single process automation use case, there is an element of AI. I'll give you a simple example. We're talking about in the banking industry, right? Let's say each of us in India, right? So, when you have to open a bank account or do anything with the bank, they do something called KYC, know your customer, right? These days it's called eKYC. Now, each of us upload a lot of documents, be it Aadhaar cards or license or passport, just to prove identity. Now, what has happened in the past is somebody physically is to verify those documents and then give a green signal saying, yes, no, you can go ahead with this person, identity is complete. Now, typically they say it takes 3 days. That means somebody is manually verifying as part of the back office operation. Doesn't make practical sense. Can we build a software? Can you build process automation here to moment you upload in the next 5 minutes, approval happens on your KYC, right? So this is where there is a need for us to automate, and that's where the power of process automation, robotic process automation, plus techniques like OCR, computer vision, etc., is making a huge difference in the industry, right? I'm just giving one example, which is eKYC, but there are thousands of examples where AI is becoming a dominant player when it comes to robotic process automation, right? Second theme is autonomous systems, right? What autonomous systems? There is no human intervention here, by the way. We're talking about systems which will understand the surrounding, understand the environment, and act aptly, right? So when it comes to when I say autonomous systems, yes, they are definitely machine learning models or deep learning model. I would say dominantly here it is reinforcement learning techniques being used, right? And I'll show you a quick example of what it really means. We are actually shifting from machine learning to machine teaching. Okay, autonomous systems, which is what we call it as a service on Azure, which basically is called Project Bonsai. Bonsai is a company that we acquired as Microsoft 3 years back, and they specialize in reinforcement learning, deep reinforcement learning, I would say DRL, and they bring in techniques where you can teach a machine. Right? Look at it this way: and if somebody spends significant time in, let's say, manufacturing industry, they bring in significant intelligence into the table in terms of the know-how on the operations. Can that knowledge be transferred to a machine as we go along. I mean, that's where machine teaching plays a dominant role. We'll show a quick example as I go along. But the point is, yes, autonomous systems are absolutely complementing human ingenuity to greater extent, right? Be it, let's say, autonomous cars, or be it a smart building, or even for that matter, if you look at flying a drone. So today, you don't think about, when I say autonomous systems, there is a level of abstraction there. Today, you don't think about, when you fly a drone, at what speed the blades are rotating, what should be the blade speed in the next 5 minutes because wind is blowing. No, you focus on what is the drone showing from a vision standpoint. The rest is all abstracted to a greater extent, right? That's where autonomous systems play a critical role in the industry. Now, a little bit of autonomous systems, right? So we're talking about, it's definitely a deep reinforcement learning based platform environment where you talk about machine teaching. And again, the big deal here is simulation, right? So why simulation? Now we're talking about systems being put into production where it will, depending on the environment surrounding, automatically it will take its own course, right? I mean, that's a dangerous statement to make, because end of the day, systems, are they as intelligent as human beings to make the decision on the fly? To an extent, yes, and that's where you need to simulate the environment, train the model, and once you're happy with, yes, it can take up these exception cases, it can handle it, then you put it to production, right? I'll show a quick example before I move on. If you look at the scenarios, right, dominantly in the manufacturing industry right now, where you have control systems. Let's say you have a machine tool, or a lathe for that matter, in the manufacturing industry. You need to calibrate that lathe machine for its accuracy from time to time. Generally, if you look at in reality, for a machine operator, for lathe operator, it takes about 4 to 5 hours to calibrate the machine so that you can run then the operations again once again. With machine teaching and with project Bonsai, that's been reduced to 3 minutes, right? So the point is, you can actually build models, machine learning models, which can absolutely complement the need of the hour when it comes to manufacturing plant and the control system, and you can deploy it for it to automatically do things on the ground. Okay. Now let me show you a quick example as I speak. Let me switch to the browser, and as you see that, okay. Just give me a second. Okay, it's here. Oops. Okay, so this is, by the way, a Bonsai simulation environment. What you're seeing right now is basically a simulation of equipment whose job is to balance this ball on the plate, right? In fact, in reality, it was also trained when you actually drop an egg, the real egg, on this particular plate. It learns to practice, right? Despite the fact that, yes, you basically train this to practice a ball, right? Ensure the ball doesn't fall off. Now, when you drop an egg, also it makes sure it balances it. Now, before you actually put into production, you need an environment where you can actually train it, and this is where basically this is an environment where you get to build a real world use case via a mathematical model here. End of the day, it's an optimization problem, right? So there is a language called Inkling. So Inkling is what you use. It's pretty much like C, C++, Python, etc. Now, Inkling is language which is what you use, and basically you import your mathematical model, and that's what is been done here. I'm just giving you a glimpse of this project Bonsai environment where you have an option to simulate the real world scenario, and what we call it is a brain. Once you've trained this particular model, you can basically export the brain, right? You can export the brain, and you can take it any platform of your choice. Okay, so the point is, you can have your own simulators. For example, if you have an air sim as a simulator, right, which you're doing it externally, you can bring in that into this environment, simulate it, train it, and export it as a brain, right? So that's the unique thing about machine teaching, and this is dominantly being done by Project Bonsai. So if you're interested to explore, just go to aka.ms/as, which is autonomous systems, which is what you saw in my slide earlier. I'll quote the URL once again for reference. If you look at this at the bottom of the slide, just visit this. aka.ms/as stands for autonomous systems. So you get access to Project Bonsai there. It's a preview, so you can just check it out. It's an interesting field, right? Where you can actually make missions adapt to make it more adaptable. That's pretty much the crux of what it is. Okay. So we'll move on. I'm sure most of you would have, heard about GPT-3. So this is again just to give you glimpse of where is innovation heading, right? I mean, this is, there is a difference between artificial intelligence and artificial general intelligence, AGI we call it, right? OpenAI Group, which basically is an open group which fosters research and development of AI for humanity. Right, that's the core purpose of OpenAI Group. Now they built this GPT-3, which is the machine learning model, basically, right? So given input in terms of who is the author and the type of vocabulary an author has, it creates fiction. As an output, it creates creative fiction. So that's the power of this this language model. And of course, it can take input and create meeting memos, etc. So this is pretty much human-like. But again, if you look at where we are on this AGI journey, yes, we are pretty much, scientists say that we're 30, 40 years behind. It will take that many years to pretty much do what humans do really well. So there is definitely and I would say AI brings in, the base promise of AI, if you look at it, is to do things that human does, right? Missions mimicking human beings, but we're very, very far from that, right? In terms of mimicking human intelligence, we have seen in scientific fiction movies, right, Terminator and whatnot, but this is pretty much artificial general intelligence is one of the evidence that I want to showcase. As Microsoft, we talk about, I would say this is a construct which is true in its entirety in the industry. We talk about cloud. Cloud dominantly is, I would say, augmenting and complementing the need that we have in the machine learning world, AI and ML world, because you want systems which brings in elasticity, which scales with autonomy. All the stuff is something which intelligent cloud brings to the table. And there's also a dominant player in the industry in the current times, and probably in the last 2 years or so, which is basically we call intelligent edge, right? Now, let me explain this. Now, what is an edge device here? For example, you might be wearing an Apple Watch or a Samsung Watch, or you might have Amazon Echo, right? Google Home, Microsoft Cortana. So all these devices, I'm just giving you examples of few IoT examples here. All those devices qualify to be an edge device, right? Now, intelligent edge is pretty much, based on my experience of working with so many customers, the need to have an edge to, the need for intelligence to be there at the edge is dominant. Simple example I'll give you. Earlier I showed you video where we are able to identify number of people in a specific retail store, distance between them, whether they're wearing a mask or not, etc. Right? So all the stuff is happening in real time at the store. That means you don't have to be making a public API call. These models, whatever models I'm talking about, machine learning models, which we call it as pre-built AI or cognitive APIs, they're actually deployed to these edge devices. The camera having a miniature compute environment, we can deploy it there, right? Now, that's the power of technology today, and dominantly container technology, right? If you look at Docker container, that's what has been used to deploy the packages models and deploy to wherever it matters the most. The point here is you're taking ML models to places where data is getting generated, because you can't afford to send a massive corpus of video data to the cloud, do some processing, and then make inference and then send it back to where the call is being made. Not practical enough because latency sinks in dominantly there. So intelligent edge is definitely here to stay for a long time, right? Look at healthcare industry. Okay? When we do remote consulting, at times tier 2 cities you not even have connectivity. Can we have intelligence there? That's where intelligent edge becomes a dire need in that context. So I'm just trying to give an example in terms of how do we decipher cloud and edge. And the philosophy is straightforward. You basically build your models in the cloud. Basically, you train in the cloud because you need massive compute, GPU emissions, FPGA emissions in the cloud. You train in the cloud, and once the training is done, you deploy to edge devices, right? I'll quote one more example as you go along. It will be a lot more clear. But there are two personas emerging, by the way, in the industry: citizen developer and citizen data scientist. So who are these personas, by the way, right? So citizen data scientist is a business user in any firm for that matter. A business user, ability for a business user to actually make intelligent inferences without having any knowledge of machine learning or statistics and probability for that matter, right? Can a business user be equipped with tools and techniques where they can make intelligent inferences? That's the need of the hour. That means the software as a construct is getting democratized to a great extent. That means it is getting it will be making it so simple that people without knowledge of machine learning, they should be able to with the data that they possess, leverage some kind of intelligence, right? We'll see how that happens. But right now, the thinking is this: there's a need for industry to be equipped with tools and techniques for citizen data scientists to stay productive. Every time you can't afford to, make a request to your data science team to build models for basic things. Can a few things be taken care of business users themselves? Answer is yes. That's where the tools and techniques are being built. Okay. Now, two things. When it comes to AI scaling new heights, there are two categories here, right? Number one, as I said earlier, I've been talking about cognitive services across vision, speech, language, search, and decision. These are dominantly being created almost for 2 to 3 decades now. It's just that you see them dominantly these days being offered as APIs because we've reached human parity. That's the only reason why these APIs are making a lot of noise, for a good reason. And these innovations are not, not. I mean, when I say innovations, I would say human parity. It's not in the long time back. Human parity on each of these. You look at the dates. It is probably in the last 5 to 6 years, right? By the way, while I'm talking, if you have any questions, I'm not looking at the chat window. Feel free to unmute yourself, ask a question. It's perfectly fine. Okay, I'll just take a pause here before I move on. Any questions so far? Yeah, it shouldn't be a long monologue, and hence I'm trying to check if any of you have any questions.
There aren't any for now, Sandeep.
Okay, perfect. Thanks.
Normally come at the end.
Sure, perfect. Yeah, we'll spend some good time on the Q&A. So if you look at these innovations, yes, in fact, 2020 image captioning, right? Ability. See, the human parity on object recognition happened sometime back, almost 6-7 years back. But image captioning, looking at an image, can we caption it automatically? Accuracy on that pretty much happened in this calendar year, right? So these are something which are making huge difference in the society, and ability for us to infuse intelligence is a lot easier because of the fact that yes, these innovations happened. I'll give you one simple example, right? If you look at machine translation, probably the hardest problem to solve, right? When it's the hardest problem to solve, we're talking about converting a Chinese essay as an example. That's actually what happened as a final test. A Chinese essay was translated to English. Now, after translation, it is given to a linguistic specialist to validate the accuracy of the translation, and it is also given to. It is given to 2 different linguist specialists. One was machine generated and one was human generated. So they couldn't make out a difference. By the way, it is not a Turing test by any chance. I mean, when it's a Turing test talks about, hey, can you differentiate this action being taken by a human being or a machine, right? It's not a test of that. But both the versions, machine translated and human translated, both are perceived to be highly accurate, right? So imagine when it comes to translation, we talk about language, vocabulary, tone, emotions, all this stuff comes into the picture. And again, human accuracy is about 67% is what I'm told, and 69% is accuracy of these models, right? When it comes to translation. So this is where we've dominantly spent. So let's shift gears. Now, while I spoke about cognitive APIs, let's talk about building custom machine learning models. Any platform for that matter. When you talk about building custom machine learning models, which probably is outside of these cognitive APIs, because some of the scenarios may not be dealt by cognitive APIs. Hence, you have to build custom machine learning model, and that's where data science lifecycle becomes so critical. Ability for a platform to embrace data science lifecycle and give you those tools and techniques to make it a reality. So Azure machine learning service does that brilliantly. I'll give you a simple example. This is one of our customers who reached out, I would say last year, and their requirement was, yes, we have got a contract to basically manage all the toll booths on Yamuna Express Highway, right? There's so many toll booths from Delhi to Agra. Now, the use case they had was at every toll booth, we are expected to do automatic number plate recognition, yeah, ANPR. It's a very popular use case, right? So using number plate recognition, as well as they also identify how many people are there in the car, not the gender, as not the who's in the car, not those information, just automatic number plate detection, as well as number of heads in the car. Now, on a regular day, looking at the cognitive APIs that we've built, there's definitely a DVR setup, right? There's a camera setup at every toll booth. Now, what they also had infrastructure there at the toll booth. So what they did was they basically made a cloud API call. Not practical at all, right? Because imagine in some toll booths, you don't have connectivity. How will you make this use case real without having connectivity? The end of that is to basically, when you make a API call, it is supposed to come back with an OCR capability where you can recognize the number plate and recognize the number of heads in the car. Now, that was also a time where we announced cognitive APIs in containers, right? So with that coming in, you could actually eliminate the entire cloud API, right? Look at this right now. Right now, we've kind of given out, right now we're giving out all of these cognitive APIs packaged in containers and helping you deploy to the places that matters most. In this case, the toll booth infrastructure. Now, for the application, the toll booth, it is no less than API call, local API call, right? So no latency, instant inferences. That's what edge inference brings to the table, right? Another very important innovation. In fact, I'll show you how simple that is to build it. All of you, who are basically in the process of understanding how to build. When we say democratize AI, how simple it has become. This is one model I built recently to identify whether somebody is wearing mask or not, right? So this is basically a custom vision.ai. This is the Microsoft custom vision portal. If you go here, if I say new project, right? You can pretty much do object detection and image classification problems here. And again, across domains. The reason why domains come in handy is because we pretty much do transfer learning, right? You also see a compact models here at the bottom. So that's for a reason. When you want to export that to an edge network, you need compacting, because edge compute will not have too much of a compute space to deploy those models, right? I'll show you a simple one which I built it. This is a face mark detection model. All you need, by the way, is 40 images, right? I've uploaded more than that, 40 of people wearing mask. I mean, that's me, and without mask, right? Reason we need very few images is because we do transfer learning. That's the beauty, right? Upload images, you have to tag it, by the way, right? You could tag whether we're wearing a mask or not. And once you've done that, you click on train. It takes about 2 minutes, and that's about your model is ready. The best part is, if when you look at once you train the model, look at this. You can export it to any platform of your choice, whether you're talking about deploying it on a Core ML iOS or a TensorFlow Android, Docker file, or no, Vision AI Dev Kit is the Qualcomm device, or the best part is ONX, Open Neural Network Exchange. This is a open interoperability standards, right? So this is one example of how simple technology has become. But let me also take you to another level, which is, hey, when it comes to custom model development, can there be automation? If you look at this visual, I'm sure if you're in the AI ML world, you would know that what does it take for us to build a machine learning / deep learning models, right? You ingest data, you do two key activities. Number one, feature engineering, right? And number two, hyperparameter optimization, hyperparameter tuning. That's what we call it, right? Now, if you look at feature engineering, yes, this is where domain expertise comes in handy. There's a need for us to basically identify features that matters most for the problem on hand, right? If you take a healthcare example, right? We collaborated with Apollo Hospital in the country as Microsoft to build a cardiovascular risk score for the country. That means if anybody walks into Apollo Hospital for a health checkup, there is a model, machine learning model, which actually bases the clinical trial records, clinical trial data. The model actually gives out whether this patient who's come in for checkup, will this person have an episode of cardiovascular near future or not, right? And if yes, you can suggest lifestyle changes, right? So what features, what data should be used from the clinical trials that will have a dominant effect on the results that when it comes to cardiovascular score assessment, right? That's where I think human intervention is very key to ensure feature engineering happens with domain specialists and data scientists, working in collaboration. But the second aspect here, which probably can be automated, is because it is process intensive, time consuming, which is hyperparameter optimization. What is hyperparameter? I'm sure you know that these are parameters you set before the learning process begins, right? These are all values that you set. Now, as you want to fine tune the outcome of the model in terms of accuracy and precision, you basically change these values. Now, can this be automated? Yes, absolutely. This is where we have a feature called automated machine learning, right? Again, we're talking so far, what I've spoken is it's pretty much a no code or low code. Okay. The platform definitely gives you an opportunity to build a model from scratch. There's no one stopping you to do that. But can there be tools which will complement your development in terms of cutting short the development life cycle? That's where automated machine learning comes into the picture. Let me just explain that visually, and then I'll take you to the portal and show a quick demo. Okay. So this basically is what we're talking right now, where, let me just minimize my video. Okay, so if you look at right now this visual, there are three things. It's a different representation of the previous diagram there. Feature engineering, right, hyperparameter optimization, and eventually the output. Now the big deal is, by the way, you should know beforehand for this to work that, hey, it's a regression problem, a classification or a forecasting problem. As long as you know that, you're all well set. But the point, which is probably the most time consuming and the most difficult one, is the middle box, which is hyperparameter tuning. So this is where automated machine learning comes in handy. I'll show a quick example here. We're looking at calculating what is the worth of a car given some of the features of a car. Okay, let's look at that. How will automated machine learning come in handy is what I want to show here. Now, when you take a simple problem, we basically choose features, right? If you look at the features of a car, what mileage does it give, what condition it is in, car brand, year, make, blah, blah, blah. All the stuff goes on, long list of features. And as a data scientist, you may be familiar with kind of algorithms you have. For example, if it's a regression problem, you may be familiar with a few regression algorithms that you feel comfortable doing the problem, and you've had good success in those algorithms. So that's a list you put down. And finally, those parameters. So how do you actually build a model? You basically take a few features, right, and you take it against a specific algorithm that you feel bases your experiments. It's again an art and science to build these models. Based on your experience, you choose an algorithm, and you also try to tune certain parameters and eventually get output, right? And by the way, all of us understand that machine learning world is synonymous to an iterative world. When we live in a world of iterations, relentlessly iteration to make sure that we get higher accuracy, better precision, etc. Right? So if you look at this, this is what you do, and you do this repeatedly, right? Till you get accuracy that you desire. You keep doing it, right? One after other, and finally, you might get an accuracy that is desirable, and then you stop, right? So after feature engineering is done, can automation happen? The answer is yes, and that's where machine learning, automated machine learning comes in handy. Look what happens here. I have ingested data. I basically identifying a few features. Now, automated machine learning, takes you through a logic where, as long as you know it's a regression, classification, forecasting, it does automatically. Okay, let me show you an example. I'll just take you to the portal right away and show you how it all happens, right? This is Azure Machine Learning Studio. And on the left-hand side, we have automation learning. And if you have to create a new machine learning model, let's do that and see how it all works. I've run it, by the way, once. I can show you what I've run, but let's start from scratch and see how it works. And I'll not run it because it uses compute. Now, here is the step. Here's what we do. Right now, I imported, same again, by the way, automobile price prediction, right? So I have new, the historical price data in this particular data set, which I've uploaded to a blob storage in Azure, right? Now, somewhere it has to be stored. I do next, and what it asks me is basically, hey, experiment name, I can say Saturday Tech, okay? And what should be the target column? Of course, we're trying to predict price. So my price will be my, Y, right, the target column. And it asks me, specify a compute cluster so that I can use that environment for training. I've already created one, which is called AML compute. But by the way, when I say create new compute, you can see, basically you can decide what kind of machine you want. You are looking at a GPU or a CPU machine, and what kind of a hardware you want in terms of RAM and core. You can do all that, right? So you can choose whichever machine you want. I've already done that, so I will not spend too much time on this. I'll just choose my AML auto ML compute that I've chosen. I'll do next, right? Okay, it has gone back. Saturday experiment. Let me just do that. Okay. Oops, why it's not taking? Okay, I'll choose the existing one. Let's say next. Okay. So here, if you look at this, it is asking me to select a task. Hey, is it a regression problem or a classification or forecasting? So I know it's a regression problem. I choose regression. I click finish. That's it. See, look at what I've done. I'll basically end up building a regression model without writing a single line of code. Okay, let me show you one which is already running there. I'll just cancel this, and we'll go and see one which is already running there in automated machine learning. Let's choose this run 9. And after you run, if you look at the models, the best part is eventually it will give you an ensemble model, right? Best of a few model output, but you have a choice. If you look at here, we have a list of regression algorithms that the model has run against, right? It has also given you the accuracy. Basically, the output is measured by Spearman correlation here in this case. You can choose what should be the output variable that you want to, what should be the measurement criteria in terms of quantifying the accuracy. So Spearman correlation, what we used here, but it is given you every single model here, right? You can actually go inside that model. Let's say, let's say I prefer a random forest. So I go inside, and you basically can take this model, export it, and deploy it, right? That's the best part. And by the way, you might most of the time that we spend as data scientists would be on visualization in terms of metrics. Yes, you also have model explanation that's available here that you can also look at as you look at these models, and a lot of metrics come in here handy for sure, right? But you have an option to basically look at visualization in terms of for you to assess and decide which model to actually take it forward. So you can convert this into your basically a Docker container, and you can deploy it. Yeah. So it can't get simpler than this, right? I mean, I've written no code pretty much here. Nothing has been written here, and By the way, if you want code, yes, for this model, it will give you a Jupyter notebook. Okay, you can go and tweak it. And by the way, all I'm showing so far, especially automated machine learning, you can use Azure ML library within Python and a Jupyter notebook, and you can pretty much build it from scratch, right? Either you can use the portal, or you can go build it, right? This is one second example I wanted to show. And third one, which probably is in my view is an acme of innovation, is giving you a very productive environment. If you're a beginner data scientist and you also want to have an environment where you can bring in code, if you have either R script or a Python script, or you want to do a drag and drop, you can do that, right? That's the best part. So again, let's go back to the portal. If you look at the designer, right, this is basically, I'll just open it, right? Look at this, right? So this is a environment where you can pretty much drag and drop your the task and get it done. Here the same automobile price prediction. So as part of model development, what do, right? We import data. We do a lot of I would say we do EDA, right? Exploratory data analysis. As part of that, we also do a lot of transformations. We do missing value imputations. All the stuff is done here, right? If you look at, I'm cleaning missing values here, I'm splitting data here, right? All the stuff is automated done here. You can actually specify hyperparameter values also here, right? So let's say, just to give an example, right? If you want to search regression, so I get all the algorithms available here. If I want to bring in another algorithm, I can just drag and drop. I can just, if I just do this, I can just get it here, right? This is what I'm talking about in terms of environment where you get to drag and drop and design your machine learning, or rather, I would say data science lifecycle is completely visualized in this particular environment, right? And typically, once you built a model, need of the hour is to expose that model as a service for consumption. And again, a click of a button on top right, you pretty much can publish it as a web service or REST API-based service. You can invoke that in your programs and use it, right? So this is just to give you a glimpse of these innovations. And honestly, what is the need of the hour is basically bring in automation into your entire machine learning lifecycle pipeline, which is where ML ops as a new stream, right? I would say new stream is a extension to DevOps for sure, but basically we're talking about DevOps for machine learning. So ML ops is gaining huge traction in terms of when I say traction, yes, people have started building models for a long time, and now the number of models in any enterprise is multiplying significantly. So you need an automation, you need a process where you can automate the complete life cycle of when new data comes in, right? Once you build a model, it not end of it's beginning of it, right? So and new data comes in, retrain it. So new data is coming in, trigger retrain. If the model accuracy is better than the previous model's output, then promote that to production. If not, continue retraining. Down the line, you also look at, hey, new data has come in, is there data drift in that, right? If there is data drift, then bring a human intervention to look at why the data drift, and then look at the model development. So simply put, the entire life cycle is something we're talking about in terms of how can you build machine model at scale, powered by, let's say, Azure DevOps and GitHub, right? I'm sure GitHub you're familiar with. So package your model in containers, right? So I'm using the term containers for sure, but dominantly this has been the best way to deploy ML model, because when you take containers is agnostic of any compute environment. You can take that container, deploy to an edge device or to infrastructure that you have in on-premise world or in the public cloud. Doesn't matter, right? So that way it is pretty much getting democratized to a greater extent. Now, one topic which I definitely want to socialize, while I'm speaking, is about building, AI responsibly, right? We call it trustworthy AI. I'm sure there are multiple terms being used: ethical AI, responsible AI. But end of the day, as we're building these models, there's a need for us to take utmost care. It can be a simple regression model class, doesn't matter, but you got to ensure that there are the responsible AI design principles are part of your overall life cycle as you build the model. So let's look at a few things here. As Microsoft, we released some some of the tools which will help you address that. See, end of the day, it is not an easy thing to. The topic is quite straightforward, but implementation is tricky because some of the ML models becomes a black box, especially deep learning, right? At times it looks like a black box because you would not know what's happening within multiple neural network inside. So that way you need tool sets, tools to complement the very purpose, very reason to address responsible AI. Now let's look at this. There are 6 design principles here. I'll just take a couple of them just to give an example of why there's a need for each one of us to consider these design principles and make it front and center as part of development life cycle and address that, right? Let's take fairness as an example. Now, this is one example where bias, right? When it comes to model, we say it has to be very fair. There should not be any bias. Now, we work with one of the North American lending company, right? This lending company basically, they give loans to startups, right? This is the use case there, and startups, anybody else. This case with the startups, seeking seed fund, initial capital. Now this model was built in, and this model was not put to production instantly. It was actually running on the sides of the manual work that is happening. That means there is a human approver on a loan after assessing risk, etc., and the model was shadowing that person. Now, when a post-mortem was done on the operations, that means basically you went back and saw, hey, how was the model behaving considering the reality? Now, the model's output basically was evident that the model was favoring, startup CEOs who are dominantly being male, right? All the male CEOs of male founders of startups were getting loans, and the female CEO, that means the startup run by female CEOs, were perceived to be high risk, right? Why was that? So there's an outright bias in that. So we went back and looked at the data historically for the last 10 years. The human approvers, they favored male CEOs as they gave loans. So because of the fact that historical data already has bias in it, that got carried over to your machine learning model also, right? So after this found out, we went back and tweaked the features to make sure this bias was removed. That means gender should not be a feature here to decide whether to approve or reject a loan, right? Gender was considered earlier, looking at the way it was approved. So fairness becomes so critical here. So these are all subtle things, but not easy to identify and fix it. So that's where your intellect is required. So second one, transparency. I earlier spoke about Apollo hospitals, right? We actually partnered with them and built a cardiovascular risk score for the country. So this is a doctor basically who basically is looking at a patient. So this system is telling that, hey, there is a high risk score for this particular individual and a probability that this person may have an episode of cardiovascular in the near future. How should the doctor believe that, right? There's some mechanism where you can show reasons why the system predicted that this person will have an episode of cardiovascular in the near future. And that's where we'll have to equip the doctor with certain tools where you bring in transparency into the model, right? By some way of showing historical view of the patient as well as some score there. So this is one example where there's a need for you to be transparent in the output that happens from machine learning model, right? So one last example, right before I stop the monologue and we can get into Q&A. Now this is an e-commerce portal, right? So let's say a consumer is logging in, a user is logging in, and they start seeing these recommendations. Now, end of the day, when these recommendations have come in for a consumer, you got to be very, very, transparent, telling them why these have been showed to a particular user. Otherwise, they'll start wondering, why is this coming to me as a recommendation? Because it doesn't, it might be a best fit or worst fit in terms of the recommendation. So being transparent as to why this product is being shown to you is very critical. So basis the system assessment in terms of the user is married, user's income is so and so, number of times user visits the store, age, all these considerations, all these information will be taken into the picture, and only then the recommendation is happening, right? So the point here is, yes, there's a need for each of us to be transparent in a recommendation and show as to why this has been done. And this is, again, you should call out that this is a decision being made by mission, and mission has made the decision considering these data, right? So this is one retail example where we're talking about responsible AI. And by the way, if you look at the previous visual, there is a clear call out saying our AI will not only help you find what you already like, but also expand your collection and the convenience of one click. And when you go inside, it says the following graphs how shows information as to how information about you has influenced the AI model. That's the dire need to make it very clear to the end user, and as part of your responsible AI principles. Okay. Now I mentioned tools earlier. Yes, you get the Fair Learn tool as with Interpret ML in a Python package available, which you can use it. And there's a very interesting research happening. This is true in the cloud right now. Confidential computing, which is the second one. When it comes to protecting data, we spoke about moving data to the cloud and training there and training there. So many times your data is encrypted, right? How do we ensure computation happens on encrypted data, right? That's where Project Seal, that you see it here, it's a homomorphic encryption technology available there, which will help perform computation on encrypted data, and so that private data is safeguarded of consumer. Okay, so this is my last slide, by the way, and my point is, yes, there is a need for us to build a better future with AI, but at the end of the day, there's a need for us to be very, very responsible as we build this system, because these systems will have a direct impact on end consumer, each one of us. Now, the statement that our president Microsoft made, right, is in a book called Future Decode, Future Computed. Future Computed is a beautiful book which each of you should refer to, because it is a very agnostic narrative there in terms of the benefits of AI and implications of AI. So Future Computed, if you look at it in Google or Bing, you get a PDF download. You can do that. Future Computed is the book, right? And their statement is made very profound, right? It's not the question of what computers can do. It is about what computers should do, right? So what the computer should do is the decision that each one of us have to take. And that's where the need for us to absolutely wear the hat of responsible AI advocate and make sure you build these models, right? So I'll pause here. Thank you so much for the opportunity. I know it's been a 15 minutes of monologue, but I can assure you that all the stuff I spoke about is something which is here and now, and something which is futuristic. And I'll be happy to take any questions you have. You can email me as well if you have any questions to ask beyond this particular session, or follow me on LinkedIn where you can connect. But otherwise, I'll take a pause. Thank you so much, and I'm open for questions now.
Sandeep, thank you so much. That's been an incredible talk. Not only have you perfected the art of completing talks within time, which I have still not done, but also, I mean, you've covered such a wide spectrum of topics, and I just love the way you've kind of gone from simple cognitive services that you provide all the way to the whole life cycle of deploying AI models and productionizing them. And it's incredible the kind of tool set that Microsoft has been developing here. Let me start with the questions. Obviously, students that are getting into this field, as you know, I'm a big proponent that students must get their hands dirty and work with the algorithms and understand the algorithms. Whereas, the tools that you have shown here require very little of that, right? In some ways, you can actually drag and drop. And, I love the drag and drop interface too, because back in the early 90s, in fact, there was a company in England called Integral Solutions Limited that created a software called Clementine, which was the first data mining, as it was called at that time, software that had this visual programming interface. And in fact, it's part of the IBM tool set now. So they got acquired by SPSS and then by IBM. So, I mean, where do you see the focus that students should have today? when they're training to be data scientists?
Okay, so here's my take, sir. That's a great question. While tools are being made to simplify to a greater extent, but unless they understand what's inside the black box, using tools will not just help. I'll tell you why I say that. Automated machine learning, I showed 3 clicks, you have a regression model built in, right? But then if somebody asks you anything beyond the model's, I would say, precision or accuracy, you should be able to explain. And for that, there's a need for us to start from understanding mathematical model. You basically have to make your hands dirty, as you rightly said. And my guidance to every student is forget these tools for a minute, right? Spend some time, spend maximum time in Jupyter notebooks or RStudio, right? But when it comes to when it comes to productionizing system, when it comes to go to market, many times programming that will take time. Can a tool help me fast track development? Right. That's where I think these tools comes in handy. Number one. Number two, these tools are not a black box. These tools are very transparent in what it is doing. Right. So when you have a model output, you should be able to go double click that, understand each of the metrics, and then explain to somebody saying, yes, I've built a model. This model is giving so and so output. And by the way, these are the parameters I chose. And you can also tweak it because each of these models, automated output, is giving you Python code base. So that means you have exposure to what happens behind the scenes. So my point is, tools are there to make you stay productive. Tools will make you look good in terms of how fast this model is built. But unless otherwise you understand what is happening behind the scenes, you will not be able to justify the outcome. So I would say, yeah, get your hands dirty. That's where you should start.
Great, thank you. So there's a question around the dark side of AI that's happening now. How do we deal with deep fakes and the ease? We've got tools, I guess, like yours, where you can give somebody's image and a video, and that image then gets superimposed so beautifully that you can't make out whether Trump said something or Obama said it, right? So how do we deal with this kind of side of AI? And
so I'm not sure how many of you caught up with this event that happened 2 weeks back called Raise 2020. That's where our Prime Minister Narendra Modi also spoke about the need for us to use AI for a good cause, right? So here is Sarabjit. In fact, this is, I'm sure you will also have a view on this. The policy, right? This all starts with regulation and policy. See, every technology needs to be regulated, right? If you follow Elon Musk and Mark Zuckerberg's debate, and Bill Gates also stepping in there, you'll understand what can be the dark side of AI, right? My point is, we look at what are the positive side of it, because every technology today, be it drone, right? I mean, you can use drone to do wrong surveillance. Hence, it's regulated that you need to have a license to use drones and outdoors, right? So right now, industry dominantly, especially India, the AI policy on ethics and responsible usage of AI is in the inception phase right now. I would say as Microsoft, some of our leaders are also working hard with policy makers to see how that can fast track it. But unless otherwise policy and regulation comes in, it's very difficult. But then, we all look at there are a lot more problems to solve in the society than thinking about the dark side of it. There is a dark side to every technology. Classic example is Terminator. If you recall what happened in Terminator movie, I mean, that's a classic evidence of technology going wrong. Or even robot, our own Indian Terminator. So my point is, let's wait for. I mean, for now, my guidance to all students is look at responsible AI philosophy. Embrace that. That should become front and center to how we look at building AI models. If you can practice that, that's where it is. So as Microsoft, we are also preaching that, evangelizing that with every discussion, every customers of ours in terms of, yes, responsible AI is so critical. Look at this, and we can help you, right? So regulation and policy is, I would say, in the inception stage and will wait. I think it's not too far. People realize that every industry is embracing AI, and this will happen soon.
Yeah, I mean, I guess the fear is, yes, you're right. Every technology, right? Even nuclear power, for example, has a dark side and a positive side to it. And I guess it's just that AI is so much easier to get your hands on if you're the bad guy, right?
No,
Compared to
absolutely.
nuclear weapons.
Absolutely.
So how, I mean, securing something like this is very difficult, isn't it? I mean,
Absolutely.
comparatively. Yeah.
Yeah. Yeah.
Um,
Absolutely.
there's another question around bias, gender bias. Chintya, do you want to unmute? I don't want to make a hash of reading out your comment. Why don't you just unmute and ask the question?
Yeah. Hello, sir. Am I
Hi.
audible?
Yes,
Yes, you
Yeah.
yes.
are.
Please
Hello,
go
sir.
ahead.
Yeah. So, sir, you gave the example of gender bias in one of the thing, and I was just seeing the Google Brain example of Go, where they created this solution, this model to solve Go examples and all. And in that, while having a competition with the world champions and all, the model took a step which the creators thought about as a bias in the model. However,
Mhm.
later it turned out to be not a bias, rather a proper step, and which they couldn't identify at that moment of time. So how does one evaluate a parameter, whether it is a bias or not, and train the model in the same way?
Got it. Fair. So two parts to it, Chinta. Thanks. It's a great question. Number one, no, right now, if there's one dominant talk in the town as model explainability, okay? So end of the day, people could go back and look at whether it's a bias or not a bias because yes, it was explainable. Now the point is, you depending on data, which we call it as a worldview, historical data, and how many of us can represent the worldview and data ever since the existence of mankind? It is not. It is impossible. Now, if you look at Google for that matter, the dominant work that happens at Google is to basically label data, right? So labeling data. In fact, there are citizen users. If you use Google Maps or if you use anything of that sort, they actually you can sign up to uh, be a data labeler. As you visit a restaurant, you can mark, what the restaurant is all about, what food, good, bad, ugly, all the stuff you can mark it. So the more label data that we have, it's better, and hence the world is not the worldview is not present in data yet, right? All the images that you get from satellites, it's getting tagged every single day by missions, right? This is where active learning happens in terms of, hey, can machine identify these and feed that into the learning cycle? Yes and no both. When it's a no, then human intervention happens to label the data. So as long as this is going to continue for a long time, and this is where techniques like reinforcement learning is taking a shape, because that doesn't depend too much on historical data, but it works on reward system, and it looks at the current situation in terms of how it should be dealt, not base your decision now with historical inferences being made, right? So that's number one. Number two, yes, look at it. We're talking about base promise of AI to be able to mimic human beings. Now, are human beings perfect? Right? We make mistakes. So machines will make mistakes because no data is pure in its existence. So don't assume the question also has, I would say, a notion that AI should always be right. No, AI is built by us. AI is dependent on data that we have created, and there is already a ton of bias, right? See, every day there is bias in our life. Don't you think so? When you go outside, you look at somebody, you make a perception of that person. There is bias in it because basis your own historical experience, you think about it, right? You go on a street, you see a beggar. What do you think about that in India, right? Man, you will have your own perception, bias there, right? Why can't we look at everybody in the same way? Not possible. So data is put by us, data is created by us, data is not a true representative of the world, and hence missions will never ever be right. The right or wrong is decided by us. It's a philosophical answer, Chintan, but yeah, let's
Yeah, sir,
be
I got
clear
the
that
gist of it.
yeah,
Yeah.
let's be clear that machines will never be right. we said, you remember the term I use, AGI, artificial general intelligence. When that becomes the reality, scientists say we are 50, 60 years away from that. That way, your Terminator becomes a reality in a positive way, right?
But I guess the satisfaction that we have of getting a hold of the bad guy as a human, we won't have with the machine, right? So if somebody makes a mistake, at least there is some kind of form of recourse, I guess, which we don't have against AI right now. So yeah, but it's interesting. I guess time will tell where we go with this. Abhishek Lomsh, you've got a long statement, and I guess is it an observation or is it a question? Do you want to unmute and?
Yeah.
Yes, so I just want to ask that how states can police or take control of what's happening online and how powerful companies are getting, because we see as in US there are discussions of how Facebook and Twitter and all these companies operate and how powerful they are. And similarly, when they see Huawei and different companies coming up with cutting edge technology, but in hostile states at the present moment, what they consider. So how states can take control. Either, on one side, they are concerned how monopolies are coming up in their own state and how these companies are getting powerful. At the same time, they are concerned about how AI is shaping up and how other states are getting so powerful with their companies, homegrown companies. So how they can do it, because even one example that we see in the big hack and the social dilemma is that these companies might be running some experiments and they might end up in the shape of riots at some other place.
Yeah.
So how states can take control of that?
It's a very difficult problem. Let's talk about two examples that come to mind. One is look at China, right? There are more cameras than number of people in that country, right? That means everyone is under surveillance. They'll know who is where at any point in time. Is it good? Not good. I mean, that means there's a massive breach of privacy, right? Now, if you look at, on the other hand, US, there is every CEO is going sitting in front of Congress. Pretty much, they've been questioned as to. In fact, I'm not sure whether you recall. This is not a good example to quote, but in the Congress hearing of Sundar Pichai, the congressman actually typed Donald Trump in the search engine. Right when they click on search, the response that came was idiot. Right. So, is it a decision conscious done by Google? I don't know. Whether people have put in so much of vocabulary to Donald Trump, answer is yes. Has the machine taken that and done it? Maybe. Right. In fact, I'll give another example. As Microsoft released a chatbot, it's called chit chatbot called Tai in Twitter. And by the way, in 24 hours, we withdrew that. Reason is simple. The Tai was actually meant to learn conversation techniques by observing people in Twitter. Right now, people in the first few hours realized that yes, whatever data you feed to Tai, she will learn that. They started teaching that machine a lot of rhetoric, bigotry, right? So she became a hate speech maker overnight. So privacy of data was compromised significantly. Machine was open enough to take whatever you gave in. Now, see, this is a debate that's going to go on for a long time. Technology for good use, and how much of it should be in public domain, how much should be safeguarded. US elections, Indian elections, it's a long debate, honestly. But I'll tell you the positive side of all this. Now, today, I know for the fact that there was an RFP by Indian government in the last, I think 8 months back, where they call for vendors who can build computer vision models where government will give them data on UID and other stuff, because in every, while you create Aadhaar cards, we've all given our pictures and biometric ID. So they want to build a model where it can help police do their job better in terms of finding out people in a search. Let's say in a shopping mall, there are surveillance cameras. Can you look for one individual who's supposed to be a convict is roaming around, right? So positive side, a lot of work is happening, but it's a very tough one, right? Because people rules are meant to be broken, and that's what people are doing right now, right? Abhishek, does it answer your question? It's again, you have to read. I mean, there's so much happening here. Hostility. The world can be a lot more better place, honestly. But technology can make it better, but that's not the case. Yeah.
Sure.
Yes, sir, I agree with you that it's taking shape, and we have to see like how things shape up and who takes control and how it actually just positively impacts us and takes out
Absolutely.
negative impacts.
I mean,
Absolutely.
interestingly, I mean, in democracies, there's also this concern, right, that the government, what is the government, and by giving a lot of data and power to existing governments, are you actually making them, winners for the rest
Yeah.
of, the world's existence, right, as in elections? So
Yeah.
interesting points you make. Sandeep, I really appreciate, and I would love to ask more questions around this. In fact, I mean, with Auto ML, one question that I had was,
Sure. Yeah.
is it really contributing from a green computing perspective? Because essentially what you're doing is you're exploding your search space and doing all sorts of hyperparameter tuning, all sorts of algorithm selection. Is it affordable for companies to really be able to run Auto ML? And is it right for the environment for us to be running Auto ML? Lots of questions there. I mean, maybe if you can give a brief answer to that, and then we'll bring this to a close, because I do realize that we've taken more time than we had asked you for.
Yeah, no, these are, by the way, I'm sure I'm in the same boat as you. Anything tech, anything interesting questions, we get debate, and that's what is keeping me going. So thanks for all the great questions. So to answer your question, Sarabjot, here is the deal. These tools, automated ML or custom vision or even designer for that matter, is dominantly built targeting users who probably at the inception stage of the data science journey, right? An advanced ML practitioner may want to stay in control of everything. They may not use it, but there's a vast fraternity of users. We call it citizen data scientists who don't care about what is underneath, but I have data in my possession, because today we know for the fact that data remains in silos across the board in enterprises. Each group, can we equip them to make, right? Let's say Excel sheet can hold millions of rows. Now I have my Excel sheet. Can I simply build a forecasting model? Why should I engage data scientists to build a forecasting model? It's a times the data, I already have it. So it is dominantly targeted at such users. But on the other hand, if you built a model, you want a great validation quickly in terms of, hey, I think gradient boost will gonna make sense. What does the machine say for this data? Because this is basically, it's ML for ML here, right? Because we're talking about automated machine learning, taking intelligent decisions in terms of which algorithm best suits for this data, and it is learning as we speak. But I would say these tools are a great way to validate your output. And again, Sarabjot, as an extension to that, right? You might start there. You need a starting point when it comes to a model development lifecycle. These tools will give you a complete code base as an output. Yeah. That can be a starting point. We take it forward and tweak how much we want to tweak and make it real. When it comes to economics of it, in the cloud, it's all commoditized. It's pay per use. In fact, not even subscription based. It's basically how much of resource you consume, how much of time this automation learning is running in the cloud. If you run for 1.5 minutes, they charge 1.5 minutes. Yeah. So that way, I would say it's a rapid application development tool. It's a RAD. It's not it's not an end of, hey, this is like acme of innovation. No, it's a cool innovation for sure. But practicality of it is something which data scientists would take depending on how complex the problem on hand.
Sure. Yeah. Brilliant, Sandeep. Thank you so much. And again, thank you for taking out the time being in the UK and coming and talking to us. It's been a pleasure to listen to you, and it's actually opened my eyes to a lot of the tools that Microsoft has been building, and I haven't been looking at closely enough. so fantastic. Thank you so much.
Thanks, Sir. Thanks for inviting me. In fact, there's one last question which says, are there tools on machine learning? I would say look up Azure ML Studio. That's free for students. Okay. So that's a drag and drop capability. So free for students, you can sign up and you can use it. No need for credit card also there. You can use it. Okay. Yeah. So I have a request, Sarabjot. Is there a way everybody can come on video? We can take a quick picture, because
sure.
When we do community events, it's a fun part is we get to see people, meet people.
Yes,
if there's a possibility, we can do that.
Yes, absolutely. So everyone, please, if you can show us your beautiful faces, it'd be great to get a photograph with Sandeep.
Yeah, I think there's a. How do we choose a view which everybody comes from the time? Okay, gallery view. Yeah, perfect.
Come on, folks. Anybody else? Everybody else? As many of you who are brave enough to show us your faces. It's not the 8 o'clock lecture that I normally take where people are half asleep. And the rest, I make sure they fall asleep. So come on, folks. Lovely.
Yeah. Wonderful. Thank you so much. This is great. So once again, thanks for inviting me, and it's a pleasure addressing you folks. And you have a wonderful Saturday, wonderful weekend, and yeah, let's go do great stuff with technology.
Yeah,
yes,
thank
great.
you. Thank you.
Thank you.
Thank you
so much. Bye-bye.
Thank you, sir.
Thanks a lot, sir. Great session it was.